In this section, you will get a quick introduction to rational functions. A rational function is a function that can be written in the form f of x equals p of x over q of x. That just means your function will be one polynomial over another polynomial. And remember, denominators are not allowed to be 0, so this denominator can't be 0. However, there are values that could make that denominator 0, and if that happens, we will get something that's called an asymptote. We're going to be talking about that in a little bit later. The domain of this particular function would pretty much be everything except those values that make the denominator 0. Just like we learned before, f of x equals 1 over x is this graph. We've seen that in a previous video. But look at g of x. If you subtract 2 inside the function, you remember that that would actually make the function go to the right 2 units. So if you take this graph, shift it to the right 2 units, you end up with this graph. Now have a look at h of x. We have 1 over x plus 1 plus 2. The plus 1 would shift it to the left 1 unit, that's why we went this way. And the plus 2 would make it shift up 2 units, which makes it go this way. So we took this graph and we shifted it left 1 and up 2. Each of the figures that we just talked about is augmented by 2 dashed lines. One is vertical and one is horizontal. That's what this is here. These dashed lines, these are called asymptotes. Here's the word spelled out. These are called asymptotes. These are lines that your graph will approach, but usually will never cross or touch. Now every once in a while, the graph will cross this line. So keep that in mind as we begin our study of asymptotes. Vertical asymptotes are vertical lines that your graph will approach. Notice how it's approaching from the right, it's approaching from the left. It's getting really, really close to this line, but it's not actually touching this line. A horizontal asymptote works pretty much the same way, but a horizontal asymptote is of course horizontal. So you can see this is your horizontal asymptote. You actually have a vertical asymptote here too. It would be the y-axis. Here the graph continues to decrease as x moves to negative infinity. However, it gets really, really close to this line in that direction. It's kind of creating a boundary for your graph. Notice how this one does actually cross here. Same thing is true for this one. We do have a crossing point. It looks like we have a vertical asymptote here, and it looks like this one is continuing to grow as x gets closer to 0 from the right, and as it approaches from the left, it looks like it continues to fall. Of course, in both directions, the graph gets really, really close to this line, y equals 1, but never actually touches that line in the far right and the far left positions. Oblique asymptotes are just asymptotes that work like horizontal and vertical asymptotes, except they're not horizontal or vertical. They are slanted in some way. These are examples of oblique asymptotes. Asymptote notation. The notation x approaches c from the negative side is used in describing the behavior of a graph as x approaches the value c from the left, the negative side. This notation is used for describing the behavior as x approaches c from the right, or the positive side. The notation x approaches c is used in describing behavior that is the same on both sides of c. So in this one, f of x approaches negative infinity, that means y gets smaller, as x approaches 2 from the left. So as x approaches 2 from the left, y gets smaller. That's what that means. Y gets bigger as x approaches 2 from the right. So x is approaching 2 from the right, y is getting bigger. So that's how you would read the asymptote notation.